talk about the competitive exclusion, so this concept was well defined by Gauss, and it is also known as the Gauss law or Gauss principle. It states that two species that compete for the same resources cannot stably coexist. One of the two competitors, in which one is superior, one is inferior, always have an ever so slight advantage over the other that leads to extinction of the second or say inferior competitor, but in the long run means there will be more chances of a species extinction of inferior species, but in the long run. And it also creates evolutionary shift of the inferior competitor towards the different ecological niche. They will sacrifice their preferable resources, preferable choices, and move towards the supplementary resources of survival. As a consequence, competing related species often evolve distinguishing characteristics just to avoid the apparent competition in areas where they both coexist. This helps to find a mate and maintain territory or homeland of each species to maintain superiority in exploiting slightly different ecological niches. A famous example of the competitive exclusion principle has been shown here in two figures. In one figure there is Paramecium aurelia species, in second figure it is Chordatum. In aurelia it is more than 250 cis species, and Chordatum is about a 70 cis species. So this one is the stronger one, and this one is the poor one, or you can say the superior species and inferior species. When they were grown individually, they grown well, but when both species put in a single tube or say in a single habitat, and what had happened here, you can see the one species aurelia is going up, but the Chordatum, it is going downward, or it is looking poor in case of its survival, because both species were grown in the fixed amount of resources, and here resources were used as nutrients. The aurelia dominated to the Chordatum species used all the resources, and Chordatum find nothing to survive. So extinction of Chordatum are more here, and as this species here somewhere streamlining, but is leveling off, maybe here it is having equilibrium, or you can say the carrying capacity. Carrying capacity is what? It is the resource availability. So as the resource was nutrients, maybe the nutrients were available up to here, and beyond this the superior species cannot go up. Doesn't matter how much superior it is, but it cannot cross this equilibrium level. If it is, it will cross it, there will be catastrophe of population. It will either come down slowly, or it will be maintained over here at the equilibrium level. These two consequences can happen with this population, and more chances of population extinction will lie with this species, the Chordatum species. Okay. One topic of the unit second had left there, and I'll discuss that topic today. It was the edge and ecotone. Ecosystems are almost always a patchwork of communities. that exist at different successional stages. The sizes, frequencies, intensities, and disturbances differ among ecosystems and create differences in what is called the patch dynamics of communities. As you can see here, it is a forest habitat, martian habitat, and lake habitat. And all habitats or all ecosystems have some differences either in any component relating to its communities, structure, composition. But where these two ecosystems overlap, and it is overlapping here and it is also overlapping here with lake habitat and marshland habitat, where these two habitats overlap, it creates the ecotone. So it is creating ecotone here and here. Along the ecotones, they have edge. Like this is the edge habitat. So these junction zones means this ecotone. These junction zones have species of each ecosystem which are overlapping, so their communities also overlap. Many species of one ecosystem overlap with many species of the another ecosystem with overlapping. In many cases, the number of species and the population density have been seen greater within this ecotone patch rather than the main ecosystem. If talk about a parasitism, it's a very common example, and I must have discussed during the first semester that cuckoo, that is a brood parasitism bird. Parasitism most probably occur at ecotone habitat between mature forest and earlier successional patches, because cuckoo lay their eggs in the nest of other birds, probably drongo and babbler, which are active mainly in early successional patches, and forest bird whose nests are existing at the ecotone. Suppose here we have a nest, this nest will lie in the interior forests, so it will less exposed to predators or to disturbances. So when cuckoos, they lay their eggs in the nest of other bird species, the chances of those chicks survival will be more as compared to the main forest. But as nowadays cutting, logging is going on everywhere, it is disturbing the ecotone forest. So an ecotone is a zone of junction or area between two biomes or two diverse ecosystems. If you want to assume it here, so one ecosystem is the marine ecosystem and one is the terrestrial ecosystem. It's a savanna, grassland, tall grasses and shrubs and all that. Ecotone is the zone where two communities meet and integrate. For example, mangrove forest. It represents an ecotone between marine and terrestrial ecosystem. And a riverbank or marshland, it represents ecotone between dry and wet ecosystem. Okay. Estuary, it represents ecotone between water and salt water. Grassland show ecotone between forest and desert. Characteristics of ecotone. It may be narrow between grassland and forest or wide between forest and desert. So altogether its size can be varied. It has conditions intermediate to the adjacent ecosystems, so it is called the zone of tension. Usually, the number and the population density of the species of an outgoing community decreases as we move away from the community or ecosystem. And last, a well-developed ecotone contains some organisms which are entirely different from that of the adjoining communities. Ecocline is a zone of gradual but continuous change from one ecosystem to another without showing any sharp boundary in species composition. As you can see here, there is no any clear and sharp line between two habitats. One is a forest and another one is the open habitat. As ecotone is creating by overlapping of two different ecosystems or two different forest types. Suppose this is the forest 1 and this is forest 2. It is merging here and this is creating ecotone. But this edge across the ecotone, this is known as the edge forest. As the ecotone is more rich in terms of species density and diversity rather than the interior and individual forests, the edge forest also have or support to a unique variety of species where they are getting species or resources from both habitats. So edge forests leave the edge effects, and that is referred to the changes in population or community structure that sometimes the number of species and the population density of some of the species in the ecotone is much greater than either community of forest 1 or forest 2, and this is called the edge effect. The organisms which primarily occur more abundantly in this zone, either in ecotone or edge effect, may not be occurring in the main habitat type. And these zones, transitional zones, have some edge species, and those species which obtain survival resources, rich survival resources from both of the forest types. In the terrestrial ecosystem, edge effect is especially applicable for the birds, because birds' richness will be high at ecotone or edge forest, right? And density of bird will also be very high at the edge forest. So richness and diversity, you will find both things high or more rich at the ecotone or edge forest. Corvid is a well-known example of ecotone or edge forest. Here you will find the edge where, suppose here the effect of corvid habitat, this is green, and here the dry land, that is the effect of pine forest of Pori and Garbal. Okay, so where the forest of corvid and forest of alpine, they are diffusing, creating the edge, and here it will create the ecotone. Edge and ecotone. Even one more example you will find here. Here it is a Sona Nadi, where the forest or terrestrial land of Corbett and aquatic ecosystem of Sona Nadi merge. It create one more ecotone and edge habitat. Here you can see clearly this edge where terrestrial land and aquatic ecosystem both are merging and creating edge 1, and here it is creating edge 2. Edge forest may be of different types. Suppose inherent we have, where we find a clear sharp line between two forest types. Suppose this is the grassland and this is the forest, and this is a clear line. But it may be human induced, where the edge created by either natural disturbance or human induced disturbance. And in case of narrow, here one habitat abruptly ends and another begins. So I don't think that you can clearly find any sharp line between these two habitats. This side there is a forest, and here we have savanna or grassland. So it doesn't show a sharp or clear line like the inherent. White, which will be white substantially and creates larger borders from point where physical conditions and vegetation do not differ from interior of patch. Convoluted, border is non-linear. It is not non-linear. See, you will find, or you can search many features of edge forest even in a single picture, in a single habitat, but just you have to think and look carefully. Perforated, border has gaps that host other habitats. So suppose this is the forest and this is the grassland. So here some depression or gap is appearing, so it can host a different type of species. Edge species are those that are concentrated in ecotones. There is a higher species diversity found on edge of an ecosystem than the interior. And these species may be many bird species. Suppose in between grassland and forest we have sparrow, bustard, lapwing, wagtail, hare, grasshopper. These species, a combination of species from the grassland. Ungulates and predators, elephants, zebra, primates. These are the animals of forest. So these species will be known as the edge species. This is the more clear picture of the same thing, Corbett. For Igarwal habitat. Ecotone. Yeah, if you want to see ecotone at higher altitude, so here we have mountain forest, here we have alpine forest, and this is a timber line, this is a tree line of alpine forest. So this patch is the ecotone and this will be the edge habitat. So second and third units are completed. We will move to fourth unit in the next lecture. Bye bye.